back to weather. We've been talking about what the factors that contribute to weather at specific locations, things like precipitation or temperature or wind. Today we're going to look more about large-scale patterns. How does weather play out over vast distances, hundreds of miles or even over entire continents? So this is 6.6 about weather patterns. The overall weather patterns are controlled by air masses. An air mass is a large body of air with similar properties to the land or water that it formed over. So it might be hot and cold, or hot and dry, hot and wet, cold and dry, cold and wet. But these cover thousands of square kilometers. They're extremely large, and their interactions are what govern some of the more common weather patterns that we see here in Kansas and, of course, over the entire continent. In North America, we have 4 major air masses. This diagram shows more than 4, but there's 4 types. There's continental polar, which is the cold, dry air that forms over the northern part of the United States and most of Canada up into the Arctic, and it can move downwards sometimes and bring down cold Arctic conditions. There's what's called maritime polar. That's the coastal northern areas where the air is still cool but not as cold, and it's also got a lot more water vapor in it because it forms over the ocean or over the coastal lands. And that's on both sides of the continent, not just one side or the other. Then there's maritime tropical, which is warmer, wet air coming off the various southern coastlines on the east coast and on the west coast. And finally, there's continental tropical, which is the hot, dry air that would form over the American Southwest and the deserts in Texas and stuff like that. And so all 4 of these different types interact together to create our various weather patterns. The way that they move is controlled by highs and lows. These are areas of high and low pressure in the atmosphere. They govern where the wind blows because the wind always blows from the high pressure area to the low pressure area. And they also do a lot to control like our average day-to-day weather. Low pressure areas tend to have cloudier weather, and high pressure areas tend to have sunny skies. That doesn't necessarily mean that make them warm or cold though. You can have really, really cold sunny days or warm, cloudy days, but it does govern like cloud formation and stuff like that. And so where these air masses come together is called a front. The boundaries between air masses with different temperatures, different humidity levels, or different pressures. They just have to be different in one way. They can be similar the other ways. So 4 types of fronts, different ways that they interact. Here's another diagram. You have a cold front come in. The cold air is advancing into and underneath the warmer air. Cold air is denser, and so as it moves forward, it pushes the warmer air up. Rising air creates clouds, and so you end up with a lot of cloud formation at the front, and often has storms and tornadoes associated with these. And then we have a warm front, where there's a warm air that's advancing towards cold air. The warm air is in motion, but it's still going to be getting pushed upwards because, again, it's less dense than the cold air. Cold air is really dense, and so the warm air gets pushed upwards, and you still have the cloud formation that we saw before, but this isn't usually as severe, and so we get clouds but not storms with our warm fronts. Then we have an occluded front. With occluded fronts, there's 3 different air masses involved, like a cold one and maybe a different cold one, and the warmer air trapped up above. These can create kind of odd, rapidly changing conditions just because the way that they interact with one another. But you don't often still see much storms and stuff like that. And then finally, we have stationary fronts. Sometimes they just sort of park themselves where neither air mass is moving very much. There's usually light wind and precipitation associated with a stationary front. On our weather maps, these are the symbols that we use. Cold fronts, we use colors because it makes it easier. Cold fronts are blue and warm fronts are yellow or red. But they also use different shapes so that when you print the maps in black and white, you can still tell which is which. So like sharp, jaggedy edges, like triangles for the cold front, and half circles for warm fronts. An occluded front has both to show the complexity. And then a stationary front has them on opposite sides of the line. The direction that the symbols are pointing show which way the front is moving. Since all of these are pointing upwards, all of these would be moving north if they were on the map. The stationary front here has them on both direct sides to show that it's not moving. So on our weather maps, we use color lines to indicate the fronts. which is what I just went through. Okay, so that's it for the notes. For your homework today, you're going to be analyzing different weather maps to see which way the fronts are traveling and what kind of fronts they are. But overall, it's pretty easy, so just keep an eye on this symbol key to help with the homework. But anyway, have a great day, and don't forget you have a quiz tomorrow on Friday, and then have a nice weekend. All right, bye.